Google Meet நடத்திட்டு இருக்கோம். வெரி குட் மார்னிங் டு ஆல் அண்ட் வெல்கம் பேக் டு உனக்கே போர் அடிச்சிருக்கு டைலாக் கேட்டு பட் இருந்தாலும் சொல்ல வேண்டியது என் கடமை. ஸோ வெல்கம் பேக் டு CMOS Lecture Design. This lecture number 19 20 ஆப்பா ரெண்டுமே 19 போட்டு வச்சிருக்கேன். lecture number 19. So to summarize the last class, actually it is lecture number 18. Okay. So what are all the key points? Anyone? This time can you summarize at least key points? வர வேண்டியிருக்குல்ல. வாட் இஸ் வெரி ஃபர்ஸ்ட் கீ பாயிண்ட் எனிவன்? அது என்னெல்லாம் கத்துக்கிட்டேன்? ஃபர்ஸ்ட் பாயிண்ட், you know what is frequency response? My first question, why frequency response? என்னமா?
Why should we go for frequency response?
Why? To determine speed limits. Okay, that is the very first key point. Why frequency response? To determine speed limit. Okay, why speed limit? You know, everywhere we are using high speed circuits, right? And I have given some example for high speed circuit. Then later, what we discussed. Why frequency domain? Before that, we have taken some example as RC circuit, right? Or RC circuit, what is the voltage across this capacitor that we discussed? Okay, exponentially increasing the output voltage across the capacitor, exponentially increasing e to the power minus t by tau 1 minus times this applied voltage, right? So that we discussed. Then why frequency domain? Why not time domain? Now I hope so you are in a position, okay, to explain or to justify this statement. Everyone is saying, okay, frequency domain is easier, okay, when compared to time domain. So what is the reason? Anyone? What's the reason? Why frequency domain? What is the unique word that I'm expecting? சொல்லு பார்க்கலாம். ஏன் வந்துட்டு frequency domain ஈஸின்னு சொல்றாங்க when compared to time domain? நான் ஒரு ஸ்டேட்மெண்ட் கொடுத்தேனே.
The differential equations can be avoided.
Or otherwise, how can I write that? Differential equations can be converted into algebraic, okay, equations. That story, you know. And later we studied, okay, what is frequency response, right? What is frequency response? What definition I have given? Formulates, okay, the response to sinusoidal input. So the condition, you want to give either sine or cosine as input, and you want to measure the output, right? So that is nothing but frequency response. Okay. Then what we studied, anyone? இதுக்கப்புறம் என்ன படிச்சோம்? And you know what is S, right? S equal to j omega for sinusoidal input. And you know how to find the angle and magnitude of a given complex number. Okay. So then we started with the poles and the zeros. You know what do you mean by pole? What do you mean by zero? Then we discussed, okay, the rule, Bode's rule, okay, to sketch magnitude plot. In that, you know, pole contributes 20 dB per decade, zero contributes pole minus 20 dB per decade, whereas zero 20 dB per decade. In that, I have given one important statement. What is the meaning of 20 dB per decade? So it's very important. So if frequency changes by a factor of 10, what happened to the magnitude? Magnitude changes by 10. Actually 10 தான் என்ன சொல்றாங்க, 20 log 10, which is again 20 dB. இதுதான் 20 dBன்னு சொல்றாங்க. Okay, nothing but very important concept. Okay, please make a note of it. You know how to sketch, okay, the magnitude plot for the given. And we started with a whole, okay, the relation between omega and tau, where omega equal to 1 by tau. Tau is the time constant for RC circuit, okay, so it becomes 1 by RC. If it is a pole, it is a omega p, okay. So with this formula, I want to start today's class. Now put the heading. What's the next topic? Finding poles by inspection. See, take the same RC circuit. This is my R. Okay, this is my C. So what is the transfer function? What we derive? V out of S divided by V in of S. Anyone? Transfer function we derived. It is in the form of 1 plus 1 by 1 over 1 plus S tau, where tau equal to RC. Okay. Now can you find the pole for this transfer function? Pole கண்டுபிடிக்க என்ன பண்ணணும்? How will you find the pole? So it becomes 1 divided by 1 plus where S equal to J omega times RC. What is the procedure to calculate pole, ma? Here, do we have any zero?
No, sir.
Do we have any zero? No. Okay. How many poles? In order to find a pole, you want to equate this one to, right? Yeah. So 1 plus J omega RC, right? How will you find the pole?
Sir,
So this one
first
becomes
we-
0, right? First, settle.
yes, sir.
சொல்ல
After
வந்தியம்மா சொல்லுங்க.
we have to equate to
இதானா?
zero, sir.
Okay. இப்போ இது பண்ணா என்ன ஆகும்? J times omega RC, which is equal to minus 1. Okay. I'm looking for omega. So omega, J omega, right, becomes minus 1 by RC. Actually, you want to take the magnitude, right? J time இருக்கக்கூடாது. So it becomes omega P, right? It is minus 1 by RC. So this is the way. Okay. Approximately, I'm telling. The pole, always it is a negative, right? It should be located on the left half of the S plane. That story, you know, just to improve the stability, right? For better stability, I can write for better stability. For better stability, the pole must be located on the left half of the S plane. That's why it is negative. But board a plot point of view, you want to take only the magnitude. So omega P, it becomes 1 by RC. Okay. Here you can find the relation. What is this omega P? This equals 1 divided, what is this RC? It is the tau. Okay. So once if you will find the time constant, take the reciprocal, you will get the pole. Okay. So that concept we are going. So this is by using transfer function. Okay. We found the pole as 1 by RC. And we know how to find the transfer function. So again, it is a, okay, big procedure, right? It takes it involves a lot of steps, right? At the, so now how to find the pole by inspection? பார்த்த உடனே எப்படி கண்டுபிடிக்கலாம் அப்படின்னா, you want to take this as node, right? You know what do you mean by node, right? Minimum 2 branches has to be connected, right? So here only I am having one pole, right? So 2 branches has connected. Take this is some node 1. Okay. Each node contributes a single pole, man. That is the concept. Each node contributes a single pole, but the condition, it has to consist of R and C. ஒவ்வொரு நோடும் என்ன பண்ணும் அப்படின்னா ஒரு போல் கொடுக்கும். பட் அந்த நோடுல என்ன இருக்கணும்? மினிமம் ஒரு ஆர் ஒரு சி இருக்கணும். இருந்துச்சுன்னா Procedure to calculate. Okay. First time I am writing it as a procedure, but next time already we know this procedure. Okay. First step, you want to kill all the independent sources, right? Or otherwise replace independent sources by its internal impedance as per our old statement. Replace all. Pen is striking. By its internal impedance, which means that you want to make Vs or otherwise Is both are 0. If it is voltage source, you want to replace that by short circuit. If it is current source, you want to replace that by open circuit. Step 2, find, okay, resistance between that node and AC ground in small signal point of view. Then you want to find C. Again, pen is tracking. Oh my god. Okay, find C between that node and AC ground. Okay, can you apply this procedure for this simple RC circuit? Again and again, my pen is tracking. I think so. I want to change my battery. You guys, please, ma, neither arrange mana battery மட்டும் மாத்திடுறேன். Give me 1 minute. Just to take this simple RC, apply this procedure. First, you want to kill all the independent sources. So make VA equal to 0. Find the resistance, okay, from the node to AC ground. Then find the capacitance from the node to AC ground. That's it. Yeah. So this is right. This is my VI. Here we are measuring V out. Now this node, right, it contributes a pole. This is my R, this is my C. So very first step, we want to make this one as a short circuit. Step 1 over. Step 2, you want to find the resistance from the node. Okay, actually this is my ground, right? It has to be grounded. So node to ground. Okay, I am using pink color. My resistance is R. Now I am using green color. Node to ground, AC ground. My capacitance is C. Okay. So this tau is, product of these two. Now this omega p, which is equal to 1 divided by this tau, which is equal to 1 by RC. So same pole we got it, right? So no need to find transfer function and all. Just simply by inspection, right? We can find the pole. This is the procedure. So got the idea? Finding poles by inspection. Got it or not? So we will play with some example, then you can understand it better. So take example 1. Find poles for this simple circuit. I have taken common source stage with resistive load VDD RD. This is my input VI, but input side I having some resistance. This is RG. Take this capacitance since it is connected to gate. Take CG. How many poles are there? First of all, number of poles. Then we will write the pole equation. First of all, how many poles? And this is my, first of all, in order to find number of poles, you want to find number of nodes, right? See, this is my node 1 and this is my node 2. So actually I'm having n1, n2. Okay. But the condition for finding pole, each node, okay, has to consist of R and C. Node 1, RG, CG. Okay. What about node 2? I'm having only RD. Okay. So according to this diagram, I will have only one pole, not two. Okay. Okay. So omega p, I can call it as. So what about this omega p? It is 1 by tau, where tau equal to RC. Here what is R? It is RG. What is C? It is GG. So it's very simple. Right. So got it?
Yes, sir.
Now take this exam. Example 2. This time go with this guy. I want to connect some load capacity. How many poles? Take your own time. How many poles first of all?
One, sir.
Okay, one pole. So omega p. What's the equation? 1 divided by. What's the equation?
RDCL.
Okay. Okay. So we found the pole. Okay. Now another interesting question. Now listen me carefully. If there is no CL, just as if there is no CL, what is the gain? Gain is nothing but my output to input. Nothing but this is my transfer function, right? So gain, transfer function both are same, right? Okay. So how to write the transfer function? What's the transfer function for this guy? If there is no CL, what's the transfer function? What's the gain? It is minus GM times RD. Okay. Now I connected this CL. Even though battery change பண்ணாலும் pen is not working properly. Now how to write, okay, the gain? Anyone? Any idea? This one we discussed yesterday. The transfer function of RC circuit. What was the transfer function of RC circuit?
1 by 1 plus S tau.
So 1 divided by 1 plus S tau. Right. This you know. Here one is, if one is nothing but, can you recall that board is flat? எப்படி இருக்கும்? You will start from 1 and here it feels a pole. Then it starts to decrease. So minus 20 dp per. Okay. This one is nothing but this starting. The voltage or the gain at 0. So here this one is replaced by actually my gain is original gain is minus GMRD. Okay. Because of this CL, now it has starts, okay, just to now it starts to decrease. So by a factor of now again this 1 plus இது எப்படி எழுதலாம்னு சொல்லியிருக்கேன். In general 1 divided by 1 plus it becomes 1 plus S by S over 1 by tau. So the general formula 1 plus 1 by S by omega, right? Where is nothing but it is a pole omega p. So here it is S divided by, okay, omega p. So this can be written minus Gm Rd divided by 1 plus S over what is omega p? It is 1 by Rd Cl, right? So it becomes minus Gm Rd over 1 plus S times Rd Cl. So again by inspection, we found the gain, okay, for this common source stage, okay, with resistive load plus load capacitor Cl. So this is the way. Any doubt in this? Do you want to repeat? Just by remembering, okay, the general formula, this one. This is the transfer function, okay. You can call it as H of S, okay, for RC circuit. So I'm going to play with only RC. So it is in the form of 1 divided by 1 plus S by omega p. Here this 1 is nothing but that initial, okay, gain. It is minus GMRD. Now because of this one pole, it starts to decrease by a factor of 1 plus S by omega p, where omega p is 1 over RDCL. So you got this, right? Now can you sketch the Bode plot for this? Can you sketch the frequency response for this? It is very simple, right? So it is my omega in terms of radian per second. This is my gain, right? Actually, initially it is Gm or D. Take the magnitude, and here it feels this pole. It starts to decrease by a factor of minus 22 per decade. So this is the frequency response, right? This is the magnitude plot. So simply see or simple diagram without any derivation. Okay, we are in a position, okay, to find the pole, to write the transfer function, nothing but gain, and we plot, okay, this guy frequency response without any difficulty. So got this point? புரிஞ்சா? So how to write the poles, okay, by inspection. From that, how to write the gain, and from that, how to plot the frequency response. Now take one more example. Slowly I will increase the complexity. So this time take this guy. Yeah, this time find the pole, and can you simply I am writing catch the frequency response. See the beauty. No derivation, no graph, no calculation, but roughly we are in a position, okay, to sketch the frequency response. I hope so you will enjoy this concept. Okay. Now how many poles first of all? This time. How many poles? இந்த டாபிக் கொஞ்சம் இன்ட்ரெஸ்டிங்கா இருக்கும். நீ ஆன்சர் பண்ணேன்னா விட எனக்கே போர் அடிச்சிடும்.
2 poles.
2 poles. Okay. Let me call it as omega p1, omega p2, omega p1 value one. Any combination you may take, right? This is my node 1. This time node 2, node 1, node 2. Okay. Omega p1, can I go with 1 over RCGG. Omega P2, can I go with 1 over RDCL? So we found the poles, okay, by inspection. Without these capacitors, and you know what is the gain, right? Without the transfer function, without this capacitor, okay, it is minus GM RD. Now I am having two poles. So general form, it becomes 1 plus omega P1. If we will add another pole, just you will multiply, right? Omega P2. Now can you substitute omega P1 and omega P2? It becomes 1 plus S times RG PG 1 plus S times. See the beauty. That's a big derivation, right? But we are writing by inspection. Now can you plot the frequency response, right? இப்போ நமக்கு போர்டு அழகா ஹெல்ப் பண்ணுவாரு. என்ன பண்ணுவாரு? This is my omega. Okay. ரெண்டு பேர் இருக்காங்க. Omega radian per second. This is my gain magnitude. Initial, right? Initial is it starts from GMRD. And I'm having omega P1, right? Assume omega P2 is greater than omega P1. Just assume. So I'm having omega P1 here and I'm having omega P2 here. I assumed omega P2 is greater than omega P1. So till omega, here I am feeling, okay, omega P1, right? Omega P1. This is omega P1 now. Okay. So starts to decrease minus 20 dB per decade. Here I am feeling another pole already minus 20. Now this pole contributes minus 20. So here the slope is minus 40 dB per decade. See the beauty? Simple our diagram na kodutanga. They have given one common source. Okay, this time input as well as output capacitors. We are in a position, okay, to write the poles, okay, by inspection. And after that, I found I wrote the gain equation, and we found the frequency response. I mean, we plot the frequency response. Purinchama? First time it takes some time,
sir.
okay. But try to understand the concept. Later, you just sit and study, then you can get the essence of this. Okay. வாழ்க்கையில் இவ்வளோ சிம்பிளாக ஃப்ரீக்வன்சி ரெஸ்பான்ஸை ஒருத்தனால சொல்லிக் கொடுக்க முடியும்னா சான்ஸே இல்லை. அது ஒன்லி பிகாஸ் ஆஃப் ரசாவி. தேங்க்ஸ் டு ரசாவி. எவ்வளோ சிம்பிளாக சொல்லிட்டாரு பார்த்தியா கான்செப்டா. Now take one more example. This is my fourth example. Now find the poles. இதை கண்டுபிடிச்சிட்டேன் அப்படின்னா then I will be happy. Yeah. How many poles? How many poles? Anyone? அப்பா
Sir, 2 poles.
நவீனா
Yes, sir.
ஆச்சா நீ தான் ஆன்சர் பண்ணுவாங்க. 2 poles. How?
Sir, அந்த காமனா இருக்கிற கெபாசிட்டர் வந்து மில்லர் கெபாசிட்டர் யூஸ் பண்ணி
ஓகே, தேங்க்யூமா. ஸோ இங்கே தான் நம்ம டேவிட் மில்லர் ப்ளே பண்ணுவார். சரியா? பஞ்சாப் தானே விளையாடிட்டு இருந்தார். ஐபிஎல்ல ஸ்டாப் பண்ணிட்டாங்க. டேவிட் மில்லர் பஞ்சாபா டீம் மாத்திட்டாங்களாம்மா? எந்த டீம் வரணும்? ராஜஸ்தானுக்கு. ஓகே. ஸோ இங்கே தான் மில்லர் தியரம். So take example 1, 2, 3. அங்கெல்லாம் பாரு 1, 2, 3 மூணுல எடுத்து பாரு. கெப்பாசிட்டர் ஏதாவது ஒரு சைடு தான் கனெக்ட் ஆயிருக்கும். எதர் இன்புட் ஆர் அவுட்புட், ரைட்? Input to ground or output to ground. But here I am having one capacitor. Okay, it is connected between input and output. நம்ம ஊர்ல நாட்டாம மாதிரி. Okay, so this capacitor is called, floating capacitor. As per Rasavi. Floating cap. Okay, cap na capacitor na. So floating capacitor. So this time எனக்கு வந்துட்டு pole வந்துட்டு by inspection. Okay, is it possible to find? What is the procedure? You want to find the resistance between that node to ground. So resistance RG வந்துரும். ஆனா கெப்பாசிட்டன்ஸ் நோடு டு கிரவுண்டா கனெக்ட் ஆயிருக்கு இல்ல, நோடு டு அனதர் நோடு கனெக்ட் ஆயிருக்கு. நல்லா பாத்தீங்கன்னா, கேன் யூ அண்டர்ஸ்டாண்ட் மை பாயிண்ட்? ஸோ இந்த மாதிரி ஒரு ஃப்ளோட்டிங் கெப்பாசிட்டன்ஸ், இஃப் த இம்பிடன்ஸ் இஸ் கனெக்டட் பிட்வீன் இன்புட் அண்ட் அவுட்புட். ஆக்சுவலி இங்க இன்புட், இங்க அவுட்புட், ரைட்? திஸ் இஸ் மை இன்புட், திஸ் இஸ் மை அவுட்புட். ஓகே, இந்த மாதிரி இருந்துச்சுன்னா யூ வாண்ட் டு நோ அபவுட் மில்லர்ஸ் தியரம். Okay, I have thought this, but anyhow I want to repeat the same concept for better understanding. Because full and full we are going to play with this guy. Miller's theorem. Miller's theorem என்னப்பா சொல்றாரு? Can you recall this theorem? Take any
Sir,
two-port network. Take any two-port network, right? Thank you, ma. I will explain. Take any two-port network, right? Two-port network, now this is my input, right? VI. So input current has to enter, and this is my output current Vout. இங்கே என்ன ஆகணும்? current has to enter into the output node. Okay. If a resistance, it may be in general நான் impedance எடுக்கிறேன். Impedance, right? Impedance na it may be resistance, or it may be inductor, or it may be capacitor, right? Whatever it is connected between input and output. எனக்கு this is somewhat difficult, okay, for my analysis. So what I am going to do, take the same two-port network. Now this is my input VI, input port II. This is my output. Okay. Now this jet has been replaced, okay, by two impedances, one at input side, okay, one at input side, okay, another one at output side. So let me call it as jet 1, jet 2. Okay, now the current which is flowing through jet 1 is I1, which is flowing through jet 2 is I2. Okay, to ground. So in the மாதிரி ஒரு circuit, if an impedance is common, okay, between input and output, the impedance can be replaced by two separate impedances, one at input side, another at output side. Okay, now this circuit, okay, it is somehow easier, okay, for analysis. Now what is the value for this jet 1? If we will derive, it's very simple to remember. So straight away I will derive, don't worry, but before deriving as usual, you know you know the difference between படம் பார்க்கறது and derivation போடுறது, right? படம் பார்க்கறப்ப கிளைமேக்ஸ் தெரியக்கூடாது, டெரிவேஷன் போடுறப்ப கிளைமேக்ஸ் தெரியணும். ஸோ ஜெட் ஒன் என்ன வரும்? திஸ் காமன் இம்பிடன்ஸ் ஜெட், இட் இஸ் டிவைடட் பை 1 minus voltage gain. If you will derive jet 2, again the same common impedance jet divided by 1 minus this time 1 over voltage gain. Please make a note of this. This is very, very important. We will derive this, right? Okay. Take this is figure 1 and take this is figure 2. Now at figure 1, can you find I1? This is take I1. What is I? I equal to V by R. Here V is VI minus V out divided by R is jet. Okay. So at figure 1, this I1 is, this is my starting voltage, right? VI, ending voltage V out, VI minus V out divided by jet. At figure 2, what is I1? This current, starting voltage VI, ending voltage 0, Vi minus 0. Okay. What about resistance? It is Z1. Take equation 1, take equation 2. Now both are I1, right? So you can equate equation 1 equal to equation 2, right? So now can you equate these two? Vi minus Vout divided by Z equals Vi by Z1. I'm looking for Z1. So Z1 equals Z times Vi over Vi minus Vout, right? Now bring this Vi to the denominator. It becomes, okay, 1 by Vi times Vi minus Vout, right? Now bring this 1 by Vi, okay, inside. It becomes 1 minus Vout by Vi. What is Vout by Vi? That is my voltage gain. So it becomes 1 minus Vi. So Z1 is that common impedance divided by 1 minus voltage gain. Okay, so this is the flow. Just you want to find, okay, I1 in figure 1 and I same I1 in figure 2. Now, if these two circuits are equal, then obviously I1 equals I2. By equating these two I1, you can find Z1. Similarly, what is the flow to calculate I2? I will leave it to you people. இங்க I2 கண்டுபிடிச்சீங்கன்னா at figure 1 what is my I2? It becomes V out minus Vi divided by Z. Here if you will calculate I2, it becomes V out minus 0 divided by Z2. Now equate these two I2 and you will end up with this expression Z2. Okay, so I repeat, it is very easy to remember the final expression. Z1 வேணும் அப்படின்னா common impedance divided by 1 minus voltage gain. Z2 வேணும் அப்படின்னா common impedance divided by 1 minus 1 over voltage gain. இதுதான் சொல்றாரு மில்லர் ஒரு காமன் இம்பிடன்ஸ் ஆயிருந்துச்சு அப்படின்னா. ஓகே, நவ் டேக் திஸ். ஐ எம் ஹேவிங் சம் டூ போர்ட் நெட்வொர்க். I want to play with this Miller theorem for some time for better understanding. I'm having some common resistance this time. R. This is my input. II. Output. I2. Take it as I1. So now this can be written like this, right? This can be drawn like this. Two port network. This R1 and this is R2. What is the value for this R1? Where R1 equals R over 1 minus voltage gain. R2 equals R divided by 1 minus 1 over voltage gain. Okay. My first assumption, if this voltage gain, right? You know, we are having inverting amplifier. Okay. If it is some minus 5, then what will happen? Therefore, your R1 is R divided by 1 minus of minus 5 becomes 5, right? It becomes R by 6. What about R2? R divided by R divided by 1 minus 1 divided by minus 5. This minus becomes plus. So you will end up with positive resistance, right? In both cases. Positive resistance. You know about negative resistance, right? So this is case 1. Now, if I am using non-inverting amplifier, if my gain is positive, and then at the time you will end up with negative resistance, right? This is one way. Okay, it may be useful in some other applications, right? Negative resistance, by using negative resistance we are generating oscillations, right? May be useful in some other applications. என்னதோ ஆயிடுச்சு. Okay, so this is one way to produce negative generation. So that's my point. So if you want to generate negative resistance, then apply. Okay, take non-inverting amplifier, connect one resistance between input and output, find the equivalent, you will end up with negative resistance. That's the beauty of this Miller theorem. Okay, so first case I played with R. Then you know how to calculate this R1 and R2. Now same two-port network, but I am playing with the frequency response, right? I'm having some common capacity. This time, can you calculate the C1 and the C2 and let me know the value for C1 and the C2? This concept is important. So it can be replaced by two capacitance, namely C1 and C2. What is the expression for C1 now? What is the expression for C2 now? I'm asking. This is my VI, II, or take V1, I1, V out, take this is I2. Okay. What's the expression? You know what you know the impedance, right? Z1, which is given by Z divided by 1 minus voltage. So now what is this? Actually this is XC1. So C1 impedance offered by XC1, which is equal impedance offered by this capacitor divided by 1 minus A. Okay, what is the impedance offered by the capacitor? 1 by J C omega. So it becomes 1 by J C omega 1 minus AV. I want to calculate C1. So this one you can write it as 1 divided by J C omega times 1 minus AV. Here 1 divided by J C1 omega. J get cancel, omega get cancel, 1 get cancel. Therefore C1 equals C times 1 minus voltage. So we calculated C1. C1 equal to common impedance is multiplied by 1 minus AV, right? What about C2? Can you find C2? Similarly, here I'm writing. Similarly, if you will find C2, the same common impedance is multiplied by 1 minus 1 over AV, right? Because Z2 which is equal to Z divided by 1 minus 1 over AV, right? So if you will calculate, now what is this? 1 divided by Z2 is 1 divided by J C2 omega. This 1 divided by J C omega 1 minus 1 by voltage gain, right? So in the ரெண்டு equate பண்ணீங்கன்னா you will end up with this equation C2. So now this is very important. Okay, actually C, what is C1? This common impedance multiplied by some factor, right? So this is called Miller multiplication factor. Miller multiplication factor. Here it is called Miller multiplication factor. So what is the expression for C1? It becomes C times 1 minus 1 over voltage. So these two expressions are equal. Okay, if a impedance is capacitor is common, that capacitor can be replaced by two capacitances one at input side, another on output side. Input side, this value is given by that common capacitance is multiplied by 1 minus AV. Output side, that common capacitance multiplied by 1 minus 1 over AV. Okay. Now with this knowledge, try to solve this example. What I have given, right? I have given this one as VDD. This is my RD. This is my VI. This is my RG. We connected this one as some C. Or if you want, you can go with the C1, whatever it is. So now, as per Miller theorem, this can be written as, or this can be drawn as, right? This R1, sorry, C1, I take it as C, that common capacitance, right, is replaced by two capacitances, one at input side takes C1, another at output side, so output node to ground takes C2. What is the value for C1 here? We know C1 equal to this common capacitance C is multiplied by 1 minus AV. What is the voltage gain of this? It is a common source, right, with a resistive load. If there is no C, okay, if there is no C, then voltage gain is given by, right, minus GMRD. So it becomes C times 1 plus GMRD. That will give you C1. Similarly, who will give you C2? It is 1 minus 1 over voltage gain. So it becomes, that is C times, right, C 1 plus 1 by GMR. This is my RG. This is my RD. Okay. So now you know how to write the pole by inspection, and you know how to uh, write the transfer function, and you know how to plot the frequency response. Okay. So if there is a common impedance, then you know how to play. So what about poles? This time two poles as he told. So omega P1 because of 1 over Rg C1, where C1 is the formula. This is the formula for C1. And what is omega P2? This 1 over Rd times C2, where C2 is this formula. Okay. And you know, this time this voltage transfer function, right? It is again minus GMRD 1 plus S over omega P1 times 1 plus S over omega P2. And you know the value of omega P1 and omega P2. Simply substitute, you will end up with minus GMRD times 1 plus S times RG C1 1 plus S times RD C2. And you know how to plot the frequency response, right? This is my omega radian per second. This is my gain magnitude. My initial, it is GMRD. Here I am feeling omega P1. I assumed omega P2 is greater than omega P1. Here I am feeling omega P2. Okay, so this is not again it decreases, right? So this is minus 20 per dp per decade, minus 40 dp. So any doubt in this? Miller theorem புரிஞ்சா? What's the time? Time அப்பா எப்படி டைம் ஆகும்னே தெரியாது. டைமுக்கு நல்லா வரும். கிளாஸ் எடுத்தா அது எப்படின்னே தெரியாதுப்பா. டைம் நல்லா ஃபாஸ்டா வரும். மதியெல்லாம் இன்னைக்கு ஈஸி டு லேப் 1:30 ஸ்டார்ட் பண்ணோம். எப்படி 4:30 ஆகும்னு தெரியாது. Okay, so that's it for today's class. I hope so you enjoyed this concept, right? ஸோ வித் திஸ் பேசிக் நான் இன்னும் ஸ்டார்ட் பண்ணவே இல்லை ஃப்ரீக்வன்சி ரெஸ்பான்ஸை ஃபண்டமெண்டல்ஸ் தான் நடத்தியிருக்கேன். ஃபர்ஸ்ட் 2 டாபிக்ஸ் ஐ கவர், சென்ட்ரல் கன்சிடரேஷன் அண்ட் மில்லர் தியரம் ஐ கவர். நாளைக்கு தான் ஸ்டார்ட் பண்ண போறேன் ஒரு காமன் சோர்ஸ். இப்போ இந்த ஃபண்டமெண்டல்லாம் தெரிஞ்சுன்னா இதுக்கப்புறம் காமன் சோர்ஸ்லாம் 10 மினிட்ஸ்ல முடிச்சிருவார். ஓகே, ஸோ வி டெவலப்டு ஆல் தி ரெக்வயர்ட் ஃபண்டமெண்டல்ஸ். So far any doubt you may ask, otherwise you can leave. Thank you, thanks for your attention.